So we should try to make it clear that the BIMS platform, as we call it, the Biodiversity Information System, is in a way a generic project, which has been used by a number of different installations, which we'll talk about just now. So what we've done is we've built something that can be repurposed and deployed anywhere. And although the FRC's focus has been very much on freshwater biodiversity, the platform itself can be used for terrestrial other purposes. It's not, sort of hard coded to only work with with a terrestrial with a aquatic freshwater aquatic context. So the goal of the platform, of the generic platform, is to provide an open source. And I'll talk a little bit more about what open source means, and user-friendly, web-based portal for sharing, managing, and visualizing biodiversity data. And our goal, in building that is to provide tools for people and societies, communities, governments to sustainably and responsibly manage our natural resources. So we're trying to just build an enabling layer in the technology stack that provides you the platform to do your work as biologists. So the platform, Jeremy and Helen already ran through a lot of the sort of user-facing capabilities. I'll just mention some of the things that it sort of does under the hood. The first is that it actually includes a full geospatial database. So you can, for example, take the database behind BIMS or FBIS, ARGIS, whichever instance you're using, and actually connect to it from a GIS like QGIS or any other database, client software, and all of the system is exposed as a bunch of tables, and you can load in the sites, for example, or I've got the taxonomy loaded here, so taxonomic groups loaded here. So you can basically load up everything and do other workflows beyond what's presented in the website. So we want to provide like a full database environment where you can actually do whatever you imagine, basically, with the platform, not constrained by what we provide in the web interface. It includes a full data model for the taxonomy and occurrence records system. So we harvest data from GBIF, as Helen already mentioned, but we have our own taxonomy model. It's not a comprehensive model, so it doesn't deal with things like synonymy and the history of name changes for taxon and so on very well. But we've tried to build it, just put enough functionality that works well for the platform, and not try to re-engineer the whole of GBIF within our own tool. You can also integrate spatial data from your own sources. So when you're working on the platform, you have an administration panel that you can go into, and from within there, there's various ways to bring in data from your own sources. So, for example, there's a tool here that you can add base map layers, and those will appear on the map. There's also there's a full like GIS engine on the back of it as well. Okay, which I won't try to show you there, but basically there's a tool that you can upload shapefiles, for example, or other GIS data sets into the platform, and then publish them so that they appear in the parts that Jeremy was showing you just now, either as these filters for the spatial filters. So all of these layers that appear in here are driven by data that you can provide to the system yourself, and there's tools for managing that data. And then there's also these layers that you can publish as overlays on the map, and these are all user manageable. So you can go in and from whichever data sources you might have published, you might find an online data source or publish it yourself, and you can integrate them into the map. And that can all be done sort of by point and click. You can also publish the data that's in the platform as maps. So Jeremy mentioned that you can download, for example, as a CSV file, the occurrence data for a site or what have you, but you can also there's a complete mapping engine behind the software, which is used to display these points and things on the map. But you could also integrate it with third-party GIS software if you wanted to. There is an extensible dashboard framework. So the dashboards that Jeremy showed you, they can actually be managed within the site, and it's sort of point and click at the moment, although there's still more things that we would like to do. But you've got a kind of a designer like this where you can actually go and arrange the components of the dashboards into whatever arrangements you want to have. You can move things around and size them to say how much space they should take up on the page and so on. And then when you save that, the FISH dashboard will show that new arrangement. So we're trying to more and more build in these kind of admin user tools that allow you to configure the system yourself, so that you don't need Kartoza. Basically, we're trying to make ourselves redundant, or that the work that we do focuses on sort of new innovations rather than just the rote management of the site. We have an ongoing effort to make all of the system options user configurable. So you'll see within the administration section of the site, there's tools for managing the taxa, uploading taxonomic lists. There's tools for managing, the taxonomic lists once they've been uploaded, and removing taxa, discovering taxa from GBIF, all sorts of things. So we try to move all of these tools that are not for the average user, but for the people that are running the site, that they can basically take agency and manage the site themselves without needing a software developer to change something every time they ask for a different taxon to be added to the list or what have you. So there's a bunch of these tools that we built, and we would like to add more of these tools as the requirements for customization arise. So for example, for the Arbus website, they wanted a different landing page experience, and so we worked with them to actually build a sort of a content management system that allows you to totally customize the landing page and add articles and so on. And also the theming, color schemes, all can be done through the administration interface. We've also built batch tools for uploading the taxon master lists and the current status. So in the long-suffering Helen and Jeremy had to deal with, because we were bootstrapping the system, they had to deal with a lot of toing and froing between themselves and Dimas, our also long-suffering developer, to actually deal with the process of moving data onto the site. But in the more recent time, we've been building the tools that allow you to do those things yourself, so that you don't need to ask a developer to do things, and again you can take agency over the platform. And then Helen and Jeremy did mention about SAS, and there are other capabilities in the platform for dealing with for example, chemistry data and so on. And the platform is extensible, so we can be adding other types of ancillary data. We've got a freshwater quality module planned with Arbus as well, and we anticipate probably in the future that more of these types of functionalities will appear on the platform. So just at a technical level, the system is built. Our internally developed code is the BIMS application, and it covers all the functionality of taxonomy and site management and occurrences and basic user management and reporting and permissions and all that kind of functionality. But then we also created basically an ensemble of different tools that are already existing in the open source ecosystem, and sort of integrated them and tried to make that integration as seamless as possible. So there's this Wagtail platform, which is allows you to, for example, write a blog or maintain a blog within the site, and also you can write help documentation and other content on the site using that. There's a citations management system. As Helen mentioned, you can add DOIs and other references onto the platform, and we've taken an existing tool and then modified and improved it. There's this complete relational database, which I mentioned, which is built on Postgres and PostGIS. These are open source database technologies, and they're really, really powerful. They can compete with the Microsoft SQL servers and Oracles of the world, and it's completely free. And so within that environment, there's the data model, which I mentioned, which is based on BIMs. But it's accessible, as I mentioned, from other desktop environments like QGIS or whatever your preferred database client is. And then there's also this GeoNode and GeoServer component, which is provides a spatial, it's almost like a content management system for spatial data. So with it, you can upload GIS layers like a shapefile, and then style them and then publish them. And then with BIMs, you can then go and take that published layer and include it in the BIMs platform. And there are many other smaller components, but these are the sort of main building blocks of the platform. And this is just a high-level diagram showing you how we sort of built all those different pieces together, and you can see the heart of the system is this Postgres database. So everything that we do either creates a table or record in a table in this Postgres database, and that's really powerful because, like I said, you can then connect to this Postgres database from other tools, but also it's a full relational database model, and we can have all the data integrity checks and quality control right down at the database level. So, for example, you can't add a occurrence record for a taxon that doesn't exist or whatever. It will give an error right down at the database level, basically, Django BIMs stores its data models in the database, and then it sort of is an orchestration component that integrates with these other pieces that are on the model here. Of particular interest are the fact that we've got the API, or Application Programming Interface, integration with GBIF. So whenever you create a new taxon, we can do a lookup on GBIF and go and see, does that taxon exist? Is it the canonical name or is it a synonym, and so on? And we do that we offload all that work to GBIF, which is fantastic. And then similarly for the status, the conservation status lookups, we offload all the work to iucn.org, which also provides an API, a programming interface for connecting to that. And then we've got these other components which, all pretty much interact with the database. One thing that I hadn't mentioned is another open source project that we built as part of this project, and that's called GeoContext. And what it does is it allows us to execute on this philosophy that we shouldn't ask users to capture data which we can derive from existing data sets. So I remember when I started in conservation, we always had these long forms which had things like, what's the slope, what's the elevation, what's the aspect of whatever sampling site you're at. But these days with GIS and open data sets that are available, one can easily just calculate those by giving the location of the site, and then it will go and figure out everything. And so we built this GeoContext platform, which basically will take a site, and this is the website for GeoContext here. It will take a site and then sort of drill down for that site on a map, and then we curate a list of web service maps, which could be, for example, average temperature per month, average rainfall per month, slope aspect, terrain height, or what have you, whatever we want to put in there, and also things like political boundaries, province, state, district, and so on. And all of them get curated in a collection, and then what the service does is allows you to pass it a point location, and then it will give you back it'll give you back a document. This isn't like nerd speak, but it's a document which describes for that location all the information from the different layers that have been registered. And with that, in FBIS or ARBIS, when you go and click on a point, all of the information for that point that is sort of contextual in nature, for example, the temperature graphs and rainfall charts, and even when you go into the dashboard, these contextual information fields here are all looked up for you, so that you don't need to go and punch in for every occurrence, for every site, all of this data. And if the data changes over time, we can relook it up and give you the fresh version of the data. So that's quite an interesting and novel piece for the platform as well. This is an early schema diagram that from maybe the first year of development, but it's still kind of relevant, and it shows the broad architecture where we have this concept of a site. In the database called a location site, and in the architecture, the site could be of different geometry types. It could be a point, or it could be a linear site, for example, if you're doing a transect, or it could be an area, for example, a conservation area, or a wetland demarcated area, or what have you. So you don't have to necessarily think only in terms of point locations, although the development thus far has been point focused. We have put in place things that in the future we could also support non-point based sites. And then for a site, you'll do a survey, which is basically a visit to that site, and you will collect records of different collection types. And this is still, it may not be exactly like this, but it's more or less the construction that lies in the underlying database. And the idea is that you can then add additional collection types. So, for example, we've added ordinata, and various other things will come in over time, which are just basically groupings of occurrence data for that site. And the combination of a site and the survey and the taxon creates this thing called the biological collection record, where again, we've got the linkage between the taxon, so we can then find out from the taxon what the taxonomy is according to GBIF, and we can find out the conservation status. There are many other tables. If I flip back to Q just quickly here and just show you this is just the list of tables in the system. So I haven't counted, but probably we have in the order of maybe 50 or 100 tables, that are in the platform. And some of them are specific to different modules, for example, the wagtail or the bibliography components and so on, or the SAS components. So everything's really nicely modeled out into this database. So I just wanted to mention a little bit about the development model. We've talked about open source, but some of you may not be familiar with the concept of open source. The idea is essentially that we use an open approach to the software as well as to the data. And other, if you come from a scientific background, you might have this idea of like a peer-reviewed open publication versus peer-reviewed publication which gets published on a closed, behind a paywall. So open source would be really software which has been developed in the open and is freely available. You can go to the website where the software is hosted and download it, and if you're technical, you could deploy it on your own system. There's no license fee associated with the software. And usually the open source business model, because everything, people need to be paid for their time. The business model is really that you engage with the developer to build the features that you need on the software, and you pay them for their time, but you don't pay for the software. You don't pay a license fee to own that software or to deploy an instance on your own computer. With this open source software, we also engage in an open process. So if you go to the to the website for BIMS, you'll see that it's wide open. Anybody can just come there. We can share the link with anybody who wants to see it. We basically got a public page here, and even the roadmap of issues that we're trying to solve is all public. Anybody can just come and see it. You can see here's a ticket created by Helen, and you know, everything she's done is all completely public, and that way, as the community around the software builds, we can share the knowledge, we can share the issues, we can share the resolutions to the issues, and that's a key part and value proposition of building an open project, open platforms, that we can all participate in this development and also share in the benefits that others bring to the project. We have an open access data framework, but I think in the last year or so, there was some sort of review of this, and while the data is still accessible, we also added the option to moderate the data. What that means is that, for example, if somebody comes to the platform and wants to download all your rhino location records or some rare fish species records, you could put a validation or a moderation step in the process to say, okay, I'm going to first send an email to the system administrator and confirm whether they're happy for that person to have the data. Within that, you can engage with the person who's requested the data and ask them why they want it and who they are and what they're doing with the data and so on. And that's really to cover, I think, for two main use cases. The one is, you know, for rare and endangered things to prevent sort of poaching and other sort of social issues. And the other one is just for a lot of the data agreements. For example, within the Arbus project, they've got a bunch of different data partners, and there is some sensitivity about, you know, if you want people to share data to the platform, and you do that under an agreement, and then you reshare it freely, it can cause some issues. So we just put the mechanism in place so that those agreements can be respected. Another key part for the development model is the use of open standards. And so open standards basically are published, well-described ways of, in the case of computer science, for computer systems to interoperate, to exchange data, to create the platform in the first place. And so we try to build the system as much as possible on open standards and on standardized ways of doing things. So for example, there's this Open Geospatial Consortium, the OGC, and they publish a bunch of different standards about how map data should be exchanged over the web, and we try to follow those as much as possible. I just pulled out some pictures. This was our sort of mind map or vision board, or whatever you want to call it, project board for the phase 1 of FBIS, which we did in collaboration with FRC. And just to show you kind of the process of how we actually built the platform, where we kind of just laid out all the ideas of what needed to be built. Those came from those workshops that Helen mentioned earlier. We laid them all out on this board, and we kind of figured out the interdependencies between things and the sequencing. So we gave version numbers and what have you to different elements, and we tried to kind of just have a mental framework that we were building things against. And then kind of just one of my favorite sayings, how does the worm eat an apple? Sort of one bite at a time. We just grab it, take one of these things as a bite of the apple, go and build it and add it onto the platform, with FRC giving a very strong direction in terms of what are priorities, and then of course Kartoza bringing in the development know-how to actually make that thing a reality. And when we built the system, we develop it on 2 servers. The one is a staging server, which is like, you can think of it like a sandbox where you can go and play around and break stuff. Both the developer can break things, and also the biologists can upload dodgy data or things that they can try stuff out without worrying about what the impact might be on the users or on corrupting something in the database or what have you. And then, so once things have been tested on that staging environment, then we deploy them onto a live server. And And that server is really the place where things that have been well tested and data that's been reviewed carefully and what have you gets published, and that supports that that goal that Helen mentioned of having having a platform where the quality of the data is more important than the quantity, and again also the quality of the data of the platform itself is more important than the number of features that it might have. I think we've mentioned a lot of these already, so I won't belabor the slide too much, but just to mention that as well as building the platform from different software components, we also tried as much as possible to integrate with these other projects. So we're going to hear from Hugo, I guess, in a future session, and from Award about the work they do with publishing water quality data, and there's this mini SAS citizen science project, and we integrate with that. So we try to not reinvent the wheel, and like work together with other potential partners using these sort of APIs, application program interfaces. We have also included the GBIF publication, the toolkit, the IPT, in the platform, although we're not currently publishing from either ARPIS or FBIS to GBIF, but the tooling is all there for doing it. We just there are some intricacies with the workflow of moving data between GBIF and then back to our platform that we still need to deal with in the future before we can really enable that fully. I think I mentioned FBIS and ARBIS as being installations. We have also done one other installation of the platform for LEDIT, which is the provincial government of Limpopo in South Africa, and they did it as it's a terrestrial database, and it's fully private because they've got all their rare, rhinos and other endangered animals in there, and they just decided at the outset they wanted it to be private, so it's not something I can show you, but there is a third instance running. And that's it from the technical side. I mean, I'm happy if anybody wants to ask more detailed technical questions, and Dimas from our team is here as well. You're welcome in the discussion session to grill us on if you want to know what version of Python we're using, what have you, but I won't go into those for now. And thank you very much. The website for the actual project is over here if you're interested to go and have a look, and we look forward to hearing from you.